Thank you for coming to my talk about Kotlin. I'm Enrique Zamudio. I come all the way from Mexico City to talk about Kotlin here in Morocco. So a little bit about me. I've been programming since a long time ago. I started with Java in 2000. I became a Java champion in 2015. And I've been working, I worked on the Ceylon project. I don't know if you have heard about it. It's another programming language. I have been working with that since 2012. I wrote the Ceylon to JavaScript compiler. So working on that project gave me a lot of insights about, it changed the way I look at languages now. So I focus a lot on the design and the features of a type system and the syntax of a language and stuff like that. So now that I look at Kotlin, I know that it has a lot of very nice features, but I have seen some like red flags, like things that when you start using the language you can get into problems and you're gonna be scratching your head for a long time. And there are also some things that will be problematic. If you use them, you're going to shoot yourself in the foot because you're going to be using some features that are going to be harmful to you and your project. So what I want to show here is kind of warn you about the things that you should not use or be very careful about with Kotlin. I'm guessing you all know a little bit about Kotlin. It's a language created by JetBrains, the makers of IntelliJ IDEA. It's a statically typed language. It has, well, one of the best features for a lot of people is that it's not Java, because I don't know why it's cool now to hate Java and dislike it. Maybe I don't know if you can convert the source code to Java. This compiles directly to bytecode. So, but it's compatible with Java. You can have a project with Kotlin and Java codes coexisting. So, and now that it's becoming very popular because Google said it's going to officially support it for development on Android. And people who work with Android, people who write Android applications are not very big fans of Java. So this is very, very good news for them. And the language has a lot of very nice features. I'm going to give you sort of a tour of all this. And in some of these cases, I will show you what not to do or what to be very careful about. One of the first features that I like about Kotlin is it has this thing called data classes. Data classes are like Java beans. You remember writing Java beans, you have to have an empty constructor and a lot of getters and setters, right? So instead of all that boilerplate, you can have just this. Those two lines of code, that's a data class. It's the equivalent of having a person class in Java with getters and setters for name and for birth date. But instead of doing all that, you just have the declaration of the class and the two fields that you need. It doesn't even have a body. The class has no body. It doesn't need one. And when you compile this, the compiler is going to add a toString method and an equals method. And the equals method is going to compare every field against the other object, so that if everything matches, then it's equal. The only thing it doesn't do is add a hashcode method. You have to add that yourself. And you may be asking, where do I add it because the class has no body? Or how do I add stuff to this class? And I'm going to show you later how. Oh, that's the constructor. It doesn't have an empty constructor. It has Kotlin favors immutability, so everything by default is immutable. It's like having final everywhere. So that's the constructor of the class. So you have to construct you have to create new instances. You call person with a name and a birth date, and it stays like that forever. You cannot change any of the values unless you mark them variable. But you build the object with all the values already in it. Another nice feature that Kotlin has is called Destructuring. It means you can take a class or some other, a list or a data structure, and extract several values from it in one single line of code. Like here, we have a person. That's the same class that I used already. And in the next line, I will extract the name and the date of birth into the variables called n and f. So that's the syntax where you see n and f between parents, and just assigning p to that, it will get the name and the date of birth to those variables. Or in the next example where you have a map, you're creating a map, this function map off, and the keyword to, it's you're creating entries in a map. So you get a hash map or some other kind of map with the Java util map interface. I'm guessing everybody has to iterate at some point in their career. They have to iterate over a map, and it's very tedious, right? It's very cumbersome because you have to write with the for each is like map.entry and the pointy thing and the key type and the value type. And then, I mean, it always happens to me that I forget, I just write the map and I get an error because I have to write map.entrySet. So in Kotlin, you iterate directly over the map. You don't have to call entrySet. And to get, you can get directly the key and the value using Destructuring. Like here, that for loop, you're going to iterate over the map, and the variable key will hold in it every iteration the key of the map and the current value. So that's a lot easier to type. And I'm not declaring any types here because we have type inference, which I'm going to talk about later. Another very nice thing that Kotlin has is functions. You have top-level functions. In Java, you don't have that. They decided to stick, instead of having top-level functions, you have static methods. So you have to add a method to a class and make it static. And in Kotlin, you can have a function living outside of a class. So it's kind of a hybrid between functional and object-oriented. And functions can receive other functions as parameters, as arguments. So you can pass functions to other functions, or you can have functions that return a function. And that's, sort of the basis for doing functional programming. So the first function there is just a regular function. The second one is a function that will receive another function called f. That's a weird syntax. It says it expects to receive a function with no arguments and that returns unit, or unit is like the same as void. And it's calling the function there. You can call that var function by passing a reference to another function. It's very similar syntax to Java method references with double colons. Only here, maybe we never use double colon like that in Java because you always have to say the name of the class or the name of the object that the method belongs to. But because we have top-level methods here, it's just double colon and the name of the function. And of course, you can just write a closure right there and pass, like define a function right there and pass it to the calling function. So you can call in var and just define a function there. You have closures. So there's no, I think there's no different syntax for lambdas. So if you have a single expression, you still have to use the braces. Another simple feature is the string interpolation. They straight copied this from Groovy. Does anyone is familiar with Groovy, the dynamic language? It's the same here. You use the $, And you can use the $sign and just the name of the variable. And when that string gets evaluated, it will include whatever is in N. So it's going to print name, John Doe. And for birth, if you have more complex expressions, you can use $ and put the expression between braces. So it's that's going to print name, John Doe, and birth, and the date. Now, type inference is also a very nice feature. It may be included in Java 10, maybe. The point with this feature is that you don't have to type the type of a value or a variable. That the compiler can infer from the type that is returned from the expression. Like in this case, it says hello, so what's the type of that? That's a string. So P is a string, so instead of having to type P string, it's just val P, and the compiler knows. For a string, maybe it's not, big deal, but if you have a map where the keys are strings and the values are lists of blah, 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 instead of having to type all that, you just say val, and the compiler can infer it. So that's very neat. Also, it can infer, for some reason, I found this irregularity in the language. It can infer the type of a lambda. A lambda is a single expression function, like this one. It says, okay, you define a function that receives a string, and the return type is going to be an int, because it's the length of the string. And the compiler can infer that. But if you define the function using a method body, like a normal function, then this last one, it won't compile. You need to specify the return type. And the return type, it goes here. It has to say :int, so that it compiles. It's actually a good thing that it doesn't have global inference. This is called local inference. You can infer things within the body of a function, but the function, the return type, you have to specify it, because otherwise you can get into some problems with circular references, and it can be indeterminate, and the type inference engine could break. So it's better that they don't add type inference in functions. Now this one is where we have to start, well, not yet, but we have to start being careful. Smart casts. So everyone has to use a typecast every once in a while, like this typical case where you have a variable that's with a very wide type, like a very general type, like object. And then you check if that variable is of a certain type, right? And then inside the code, inside the block of the if, you know that P is a string, right? So you know it, and the compiler knows it, and anyone who reads this code has in their mind that P is a string, so there's no need to cast. The compiler will do it for you. So if you don't have to write a cast, you can never write the wrong cast. And that's why it's called a smart cast, because you're smart enough to know what the type is there, and the compiler also, so you cannot be wrong about it. Because when we do it in Java we will have to write here like string between parents, and then enclose the P in another set of parents to be able to call to uppercase, right? And when you use a cast, it's like you're telling the compiler, get out of the way, I know what I'm doing, and 90% of the time that's not true. We don't know what we're doing, and you can write the wrong cast, and it breaks at runtime. So instead of doing that, with SmartCast you don't need to do that, so you cannot be wrong because you never typed that code. But I hate that if you have SmartCasts, why did they leave them there? I mean, you can still do cast. Like in this example, now P is an int, And in the condition, I'm checking if p is an int. And inside the code, I can still cast p to the wrong thing. I'm casting p to a string. This is going to compile just fine, but it's going to break at runtime. So in contrast with SmartCast, I call this a stupid cast, because you can still do mistakes here. And I don't know why they left this in the language. I mean, if you have SmartCast, you don't need to ever do a cast. Why did they leave this syntax? It shouldn't even exist. I mean, this is one of the best features of Kotlin. It has Typesafe null. This means you can catch a lot of null pointer exceptions at runtime. I mean at compile time, right? I mean, raise your hand if you have ever had to fix urgently a null pointer exception when your code is already in production. Yes? Keep your hand up if it has been in the night or in the weekend. And then you hate whoever wrote that code, right? And even if it was yourself. In Java, it's very easy to get rid of null pointer exceptions. You just have to be very disciplined and add a lot of code saying if this is not null, if that is not null. But we don't do it because it's horrible. So in Kotlin, you can get rid of null pointer exceptions very easily. What they do is whenever you have a declaration, like here you have a p, it's a variable and it's type of string. It can only receive strings. It can never receive null. In Java, anything can be null. You declare any variable and you can always assign null to it. And in Kotlin, you can never assign null to anything unless you mark it with a question mark. If you add a question mark at the end of the type, then you're saying that can be nullable. You can assign null to it. And then you have to, in this case, for example, the compiler will infer that it's a string. If you want it to be a nullable string, you have to specify the type yourself. The syntax is like Scala. It's the variable name, then colon, then the type name. So you have to add by default. What does it? Well, you don't have to assign it right away, but because by default it's immutable, if you define a value, you can define a value and not assign anything to it yet, but it's unassigned, just like in Java. It works like the same as saying final string x, and then below maybe you can have a code with an if and an else, and the compiler will check that all the paths assign some value to it before you use it. Or you can just assign it right there. If you define a variable that's like nullable, this one you could leave it alone and then it would be null by default if you don't assign anything to it. So how does this work? You have the variable that is nullable, and if you have a function that takes a string, you cannot pass that variable to this function because the variable is nullable, but the parameter is not. So if you try to do this, you get an error at compile time. It won't let you compile that code, so that the null pointer exception can never happen. If you want to pass that nullable to this function, you have to do this check. And then the compiler, because it has the SmartCast, if you check that x is not null, inside the block, it will know that x is a string and not a nullable string. So you can now call the function and it will not break. It is forcing you to check when something can be null, it is forcing you to check that it's not null. So with this, it's like you can say goodbye to null pointer exceptions. Except, for some reason, they added a kill switch for this feature, and it's that double bang. If you have a nullable string and the function that only takes strings, you can force the compiler to do this, right? I think it's very appropriate that it's a double bang, because I see it like a double barrel shotgun pointed straight at your foot. It's straight down. You're gonna shoot your foot with this. And this is a horrible feature. They shouldn't have added this. My guess is that maybe some early adopters or someone in the team complained about having to write a lot of code to validate that it's not null, because they weren't used to do that in Java, and now they have to do it. And it's like, yes, you have to do it, but it's for your own good, because that the code will never break. You will never get an exception. But with this, you can go back to the times when you have null pointer exceptions. And you know, I really don't understand the reason for this, because you also have in Kotlin the null safe operator, and it has even less characters, so it's easier to write. I mean, like for example here, you have a function that takes a nullable string. If you want to operate with nullable values, instead of doing the whole if and working inside the block, you can use a question mark between the value and the dot. So this expression evaluates to, if S is null, just return null. But if S is not null, then evaluate what's next. So it will give you either null or the length of the string. If you want to pass, like going to the previous example, when you want to pass a nullable value to the function, and the function does not take null, you can do that. You have the Elvis operator. You're familiar with that? It's question mark then colon. So it's like the ternary operator, but the one in the middle is gone. It's called the Elvis operator because if you look at it sideways, it's like Elvis with his big hair and his eyes. So that means if X is null, then use the value that's like a default. Use an empty string. But if X is not null, then just use it. And with this, you don't need this, right? So, because you can do this or you can do this. You even have to write more code for this. It's one more character. And this will break at runtime, and this will not. So, I mention this and I make a lot of emphasis because there are already, people have analyzed like real-world Kotlin code and have found that it is sprinkled with double bangs all over the place. People are using this a lot because when you are new to the language and you're not familiar with maybe with the philosophy behind it, you start working around it to feel familiar with your old, where you're coming from, which is maybe Java. So people are using this too much. It should be like 0 times in your code. So please, whenever you write Kotlin code, don't use double bangs. Why do I worry about this? Because maybe in the future I will have to maintain someone else's code, and if it's written in Kotlin and I find a lot of double bangs, I'm going to be angry. So another feature of the language, my rant is over. You have operator overloading, like in C++ or Scala, but the way they implement it here is a little weird. It's informal. It means there are certain method names that can be used for operators. Like in this case, I'm showing you plus and times. That means, as you can see, I'm defining these two methods in the class, and they say operator. So because of that, it takes them as operators. They have to take only one argument, and the return type will be, it has to be the same as the argument. So you have these operators, right? And the way you use them is like this. It's very easy. You can have values of this type, and you only use the plus operator or the multiplication instead of having to write the method. But you can also do this. You can call the method like a normal one, right? The problem with this is it's informal, so you don't have an interface. It's like if you had defined an interface, I mean, well, if the creators of Kotlin had defined an interface like summable or subtractable or something like that, defining the method inside the interface, you would have to extend that interface. Why is this important? Because for using the like this foo class, if I just want to use it, I just add 2 instances. But if I have code that somehow wants to know, if I have code that is using reflection and I want to find out if a class can be used or it has the plus operator, I have to go and inspect if it has that method and if the method is marked as an operator. It would be just easier to say if P is summable. And then I would know that it has the plus operator, right? But instead of that, it's just very informal. And the other thing is, if you're not familiar with Kotlin yet, it's not very clear what operators you can implement like this. I showed you plus and times, but right now I don't remember how the name of the method that you have to use for division, or minus for subtraction. But for example, divide, I don't know if it's divide by or divide. You would have to like trial and error to see which one is. And also here I'm defining the plus method and the plus operator. And the plus operator receives another foo, but the plus method receives an int. So what do you think will happen when you try to compile that code and run it? The bottom line, it doesn't compile because foo that takes an int, I mean the plus that takes an int is not marked operator. So you can write foo dot plus 1, but you cannot use the plus sign on this because it's not an operator. But if you're new to Kotlin and you're writing this and you want to, maybe you say, oh, I'm going to use the plus method because I want to use this like 1 plus 2. And it's not compiling. You have to go back and make sure that you mark the function to be an operator. Now, this feature is also very nice. But it can be it's very powerful, but some people tend to overuse it. Extension methods, remember the person class at the beginning, and it doesn't even have a body, so how do you add methods to it? You can use extension methods. Like, I'm adding the debug method to this class, and it's just outside. What I do is declare a top-level function, but I mention the name of the class and then the name of the method. That's why it says fun person.debug. It's a method that goes inside it will be placed inside the person class. So whenever you have an instance of person, like the variable p that I was using, you can say p.debug. Yes. Yes. Yes, it creates in Kotlin you can have many declarations in the same file. It's not like Java where you have to only have one class per file. You can have many classes in one file, but when they get compiled, they have their own dot class. Yes. You don't even have to have the source code of a class to write extension methods for it. You can write extension methods for string or for some other class in a library. If you have a logger, you can add extension methods to it. And that's when you can maybe start to get into problems, because if you can add a string, like maybe you think, oh, I'm gonna add an operator for a string, like the multiplication, so that if I give it a star and multiply it by 5, it gives me a string with 5 stars. If you do that and put it in a library, someone else can also do the same thing and put it in another library, and then I want to use both libraries, and there's a conflict because there's duplicate code in there, and I can't load both libraries, so I have to choose one or the other, and it's a problem because I didn't even want to use that method. I want to use something else in the libraries, but I cannot load both because of that, because there's a conflict, right? Or if I want to add that in my code and it's already in a library, then I can't. So you have to be very very frugal about this. You don't overdo it, because you can create conflicts for other people when you put this in libraries and things like that. You can also override operators, and it can be weird because if you add the plus operator to this class, if I use your code, remember that code is meant to be, it's like a form of communication between programmers. The code is not meant for the machine. The code is meant for others to read. So if I read your code and I say 2 instances of person and you're adding them, and I go to the code and I see that person is a data class, there's no plus, I'm thinking, oh, so maybe someone added this, but where is it? Because it might not be in the same place. The extension method may be somewhere else, and I have to go hunt and look for that method. So that's like a problem. Looking at the codes, it's not obvious now. When you can see codes and you're calling a method in one class, and you go to the class and the method is not there. So you have to guess that it's an extension method, and now you have to find where it is if you want to know what it does. The IDE will help you with it, but if you don't have it at hand, or it has to reverse the code. And now this is maybe my second most, the feature I dislike the most about Kotlin. The second one, because the first one is a double one. But this is very confusing. Is anyone here familiar with Groovy or Scala or Java 8, the lambdas? So you have probably written code like this. You have a list and you have the for each method and you pass a closure to it, right? I mean, what do you, in the language that you're familiar with, what would this do? The code. You would expect this code to print 1, 2, 3, all done, right? Because that if the variable is greater than 0, which it always is, it returns, but it returns after printing, so it's basically useless, that code. So you would expect this to run, when you run this, you would expect it to print 1, 2, 3, all done. In Kotlin, it doesn't. In Kotlin, it prints 1, and that's it. Because the return gets you out of the closure and the calling method. Yes, that's horrible. It's very confusing. You have to keep in mind that Kotlin came out before Java 8. But even so, I mean, Scala was already out, and Groovy was already out, and all the other languages in which you can do this, they already existed. And return works like we're saying. It gets you out of the closure. But for some reason, these guys decided to make it work like this because they say it's less confusing. Because it's like, when you see the code, if you're not familiar with closures and stuff like that, if you see the code, it looks like this is a code block, a regular code block inside the function. So return, you would expect it to return from the function. But that's only true if you've never written a closure in your life. It's like if you're new to programming and to functional programming, maybe that makes sense. But for everyone else who is already familiar with functional programming or who has used closures in JavaScript or Ruby or Scala or all the other languages, this is very confusing because you will spend hours scratching your head and saying, why does this return from the function? And that's because that's the way Kotlin behaves. If you want this return to get you out of the closure, you have to write something very strange, which is return at for each. It's like you specify the context, like how far you want it to return from. And that's really confusing. So be careful when you read, especially when you read code. When you look at someone else's code in Kotlin, which is how you learn to program in a new language. You already know how to program, but you're learning a new language. You write code in that language, but you also you read a lot of code in that language. And when you're reading Kotlin code for the first time, really, you have to really remember this. The return like this will get you out of whatever is inside, not only get you out of the closure, but also the method that it's in. So that's really confusing. Sorry? Oh, what would you use to get you out of the closure? Oh, you can use while or for. A regular, you have for, like I had it in one of the. Yes, I think break and continue work normally, but return gets you out of that. I don't know why. Closures are functions. These will get compiled to a regular, like anonymous class with everything, because you're only not seeing the parents because they're optional, which also can make this a little confusing. I mean, it looks cleaner, but it can be confusing at first. But yes, these braces, everything, this block after for each, it is a closure. So that's why it's more confusing, because you start to doubt if it's really a closure or not, because the return behaves like if this was just a code block. And for each is not a keyword, that's a method in the list. So with this, that's all the presentation. I don't know if you have any questions about this. They are giving support to Kotlin. I think Spring 5 is going to have some sort of support for Kotlin, maybe in the configuration or annotations or something. It's growing fast, and that's why I want to give this talk, because I know that now many people want to learn Kotlin. These features that I showed, some of them, I mean, all the features that I showed you are very nice, but especially the double bang and this return, the non-local return, are like very, the double bang is a very bad thing. The non-local return is very confusing, and the extension methods can be very confusing if you've never used them. When I looked at it, I thought about Objective-C, because Objective-C has categories, which is basically the same thing. And I remember using categories in Objective-C, and it was it could be confusing because you would see code where you're calling a method that's not defined in the class, and you would have to go find, someone defined that, but you don't know where it is. So now you have a problem with your dependencies because you don't know if you can remove one, because maybe the extension method is there, and you remove a dependency, and suddenly the code doesn't work anymore. So yes. It supports streams, but Kotlin has its own collections, and they add also, no, sorry, I'm lying. It's not that it has its own collections. It has a lot of extension methods for the Java collections. So you don't have to use streams. You can use streams, it's compatible, but you can use their extension methods on the regular collections, and just which receive map, filter, reduce for each, and all that. Yeah, I can't remember if they implemented that, but you could use streams for that because the Java streams have the parallel thing. So you can use that and pass a Kotlin closure, and it will be compatible with the Java 8. Any more questions? Yes? Oh, sure. I guess I'm going to publish it. I will tweet it. I will post it somewhere, and I will tweet the link. So, and that's how I make you follow me on Twitter. Sorry?